Hello everyone. So today I'll be doing physics for class 8, and before we start, so I hope you all are having a good time at home, and I hope you all are also studying at the same time. So please your time in a constructive way and just don't engage yourself with the phone playing games all the time. So today I'll be doing class 8 physics, and the topic is force and pressure. And before we move on to pressure, first we'll discuss force. Now you all very well know what is force, isn't it? You've been discussing, you've been dealing with it every now and then since your junior classes. You've been learning about it, and you know the definition of force very well. But still, let us discuss briefly about this term force. Now, what is force? Force is a cause, that means it is used to make an object stop, a moving object stop, or object which is at rest move, or it also is used to change the shape or size of an object. So basically, a force, when an object which is moving can be stopped by applying a force. Or let's take an example of a cricket. So a batsman, when the batsman hits the ball with the bat, so if a fielder catches the ball which is moving will be stopped. That means the ball which is in motion comes to at rest. That means it changes its position from motion to rest when a force was applied. Similarly, an object, say an object which is lying on the floor and not moving at all, say the utensils at your home, at your kitchen, they don't move on their own unless and until you pick it up or you move it, or your parents, somebody does it, isn't it? So, unless and until you apply a force on an object, it does not change its position. If there's any other external force, perhaps. So force is defined as the cause which changes the state of a body or shape or size of an object. For example, when you stretch a rubber. When you stretch a rubber, you're applying a force on the rubber, isn't it? And the rubber band will change its shape, also the size. And when you squeeze or a sponge ball or a cotton, anything, when you squeeze it, it changes the shape. So what does a force do? A force changes the state of a body, shape or size of the body, or it can also be defined as a push or pull of an object. And you've always learned the definition as push or pull of an object. Now, what is the SI unit of force? Unit plays a very important role in physics. Why is unit necessary in physics? Because physics deals with measurement, and every time there is measurement, a unit is required to know the quantity. What quantity are we discussing about? So, when we talk about force, which is the unit of force, the SI unit of force is Newton, named after the famous scientist Sir Isaac Newton. So, Newton, when you see the term Newton, that means every time when you see the term Newton, the quantity that should come into your mind is force. So force is the SI unit of, Newton is the SI unit of force. The other units of force are dyne, which is the smaller unit of Newton, that is dyne. It is the CGS unit of force, kgf and gf. Now what is kgf? kgf is the force of gravity on an object or any object which has mass 1 kg. That means the force of gravity on a body of mass 1 kg is called 1 kgf. And the full form of kgf is kilogram force, and the full form of gf is gram force. So kilogram force is used for measuring larger quantities, larger forces, and GF is used for measuring smaller amount of force. And the relation between kgf, 1 kgf and Newton is 1 kgf equals to 10 Newton. And this is important because we might be doing numericals based on this. So you need to know the relation between kgf and Newton. So 1 kgf equals to 10 Newton. Now, as we discussed that a force makes an object set in motion, isn't it? That means you can move an object with the help of force. A force can do that. For example, if I roll a ball from here, the ball will roll to that corner. If there's no ball, it will continue rolling. So, but that is for an object which is free to move. What if there are objects which are not free to move, isn't it? For example, windows, doors. They are not free to move. You cannot just push your door and the door just falls down and pick it up again, isn't it? It doesn't work that way. So what do? You have to open the door, close it, but it doesn't open the entire end, isn't it? It is fixed at one point. So when you apply a force on objects which is fixed at one point and they rotate or they turn about, that force which we apply on a fixed object is called moment of force. And this moment of force depends upon two factors. One is force, the other is the perpendicular distance from the fixed point. For example, see here, a door. We'll come to spanner later. First, door. Now, this is the handle, this is the fixed point of the door, and the handle is always at the end point of the fixed point, isn't it? So, when you apply a force, here, when you apply a force, it becomes easier for you to open. But when you apply a force closer to this handle, say you apply a force here, and when you try to open the door, it becomes quite difficult for you to open it. It becomes comparatively easier when you change your distance. That means as you move farther from the fixed point, as you move farther and farther and farther from the fixed point, it becomes easier for you to open the door. That's why the handles are always at the end of the door, not somewhere in between or closer to the hinges. Okay, it is always away from the fixed end. Similarly, when you are using a spanner, when you are opening a nut with the help of a spanner, so where do you hold it? You hold at the end. You don't hold it over here. You hold it at the end. That means from the fixed, which is the fixed point, you hold it from the farthest point. Okay. So what are you doing over here what is happening over here? When you are keeping the handle at the extreme end or when you are holding the spanner at the extreme end, you are increasing the distance. That means when you increase the distance, the moment of force will be more. That means the force applied on the object will be less. So you don't have to apply much force when the distance is increased. More the distance, more will be the moment of force. So lesser should be the effort then. So what is moment of force? Since moment of force depends upon two factors. One is force, the other is perpendicular distance. So it is nothing but the product, that means the multiplication of force and the distance from the fixed point. So whatever is the distance here and how much the force you apply, when you multiply them, that will be your moment of force. That's why the formula of moment of force is given as force into distance. And the SI unit of moment of force is taken as Newton meter. Now please remember this. Work done, the formula for work done is also force into distance. And the unit of work is joule. And the same expression is for moment of force, that is force into perpendicular distance. But the unit of moment of force is Newton meter and it is not joule. Please remember, in order to avoid this confusion, so the unit of work is given as joule, though it is also Newton meter. So it is given as joule and the unit of moment of force is Newton meter. You are not supposed to write it as joule. That would be wrong. You should write Newton meter for moment of force. So, how does it depend? The moment of force depends upon two factors. One is force, the other is perpendicular distance from the fixed point. Longer the distance, that's why when you do the fishing, you take a long rod. You don't take a shorter one, isn't it? Because the force applied would be, the effort applied would be less. So the moment of force would be more. The same way when you're opening the door, as I told you, the handle is always at the extreme end. Similarly, when you are driving a steering wheel, the diameter, isn't it? You hold at the edges. You don't hold it closer to the fixed point. You don't hold it closer to the wheel. You hold it at the edge. So when you're driving, the same way. So all these are related to moment of force, and it depends upon two factors. One is force, the other is perpendicular distance. More the magnitude of force, more will be the moment of force. Larger the distance, more will be the moment of force. Now, conventionally, if the effective body is turned, that means if you rotate the body, the fixed body, if it rotates in anti-clockwise direction. Now, anti-clockwise and clockwise, you know very well. How does the clock move? From right to left. And how does anti-clockwise move? From left to right. So, if the body rotates from left to right, that is called anti-clockwise moment of force, also called anti-clockwise moment, and it is taken positive. Now this positive and negative is used when we do numericals based on this. However, you don't have it in your syllabus, so this is only for your knowledge that you take the anti-clockwise moment as positive, and the clockwise, if the force applies any object to rotate from right to left, that is clockwise, then it is called clockwise moment and it is taken negative. Now we'll be doing some numericals based on moment of force, and I hope that you people have understood what is moment of force, because this is something new for this class 8 students. So if you have any doubt, any queries, my number is given there. Please feel free to ask questions. So, we'll be doing numericals based on the moment of force using the formula of moment of force, which is M. Moment of force is equal to force into distance. Now, the first question here. Find the moment of force of 25 Newton about an axis of rotation at a distance of 0.5 meter from the force. And I've told you this many times, every time there is a numerical, you need to understand from the unit itself what are the quantities given. Here, force of 25 Newton is given. That means 25 Newton is your force. How much is your distance given? 0.5 meter. The formula for moment of force is F into D. So you simply have to put the value of F and D and multiply them. So what's the value of F? 25 Newton. What's the value of D? 0.5 meter. When you multiply them, you get it as 12.5 Newton meter. Newton meter, not joule. Just remember that. So this is your first question. When the question asks you to find the moment of force, and if the force is given and the distance is given, you simply have to multiply force into distance. The next question, the next numerical that we will be doing today is the moment of force of 20 Newton about a point is 2 Newton meter. Find the perpendicular distance. Now here, the question is asking you to find the distance. So what should be given? Moment of force and force. Because these are the three factors that is related to moment of force. So moment of force, the formula for moment of force is F into D. And you have to find D. So moment of force, what's the unit of moment of force? Newton meter. So which number is associated with Newton meter? 20 or 2? It's 2. So which means this 2 Newton meter is not your force, but it is your moment of force. So how much is your moment of force? 2 Newton meter. And how much is your force given? 20 Newton, because Newton is the unit of force. Now, to find the perpendicular distance, the formula is moment of force divided by force. So, how much is your moment of force? 2 divided by 20. So, 2 divided by 20 is 1 by 10, which is 0.1 meter. Meter is the unit of distance, and that's why we write meter. Writing the correct unit is very, very important. So here you might be confused because I am not put the values here. I am saying it verbally. Moment of force. So how do you calculate distance? If moment of force and force is given, distance is equal to moment of force divided by force. Moment of force here is given as 2 Newton meter divided by 20. 2 divided by 20. When you do the cancellation, you get 1 by 10. And when you divide 1 by 10, when you convert 1 by 10 into decimal, you get it as 0.1 meter. So this is your answer. So these are the 2 numericals that I have done for you people, and I expect you people to do similar sums from your textbook. They are exactly similar sums. I have only altered the numbers so that you people can do sums which are there in the textbook. So these are exactly the same questions, only the numbers are altered. So please do the sums which are there in the book related to moment of force. All the sums related to moment of force. I think there are 3 to 4 sums. Please do it. And till we meet again with further explanation of this chapter. Till then, I want you people to revise, learn, practice and study and stay home, stay safe and stay happy. Thank you.